Hey everyone, welcome back and let's write some more neat code today. So today let's solve merge intervals. We are given an array of intervals with a start and an end value. So an interval is a start and an end value. You can think of it like a class or a meeting or some kind of time period or whatever. And for each of these intervals, we want to take all the overlapping intervals and then merge them. And then we're going to have a new output array of intervals, and since we merged the overlapping intervals, the result is going to be non-overlapping. So in this case, we see we have interval 1, 3 and 2, 6. So these two are overlapping. We can merge them into one interval, 1, 6. The remaining two intervals are non-overlapping, so they do not get merged. And then we see that the output has 3 intervals, one that we had to merge to get, and then the 2 original. And this second example just basically clarifies that if we have one interval, 1, 4, and a second interval, 4, 5. Now these aren't technically overlapping in a sense, right? Like we have 1 to 4 and 4 to 5. So they clarify that these two actually do count as overlapping. So what's a good and efficient way to solve this problem? Let's say we're given the exact same 4 intervals that we were given in the original example, but notice this time they're out of order. This one is 1, 3, this one is 8, 10, this is 2, 6. It was originally over here, right? They had given the input to us in sorted order, right? So that's kind of a hint that it might be helpful for us to keep our intervals in sorted order. But what's a good way to kind of visualize what's actually going on with these intervals? These numbers are pretty descriptive, but it's better to have a picture to look at. So I'm going to draw a number line, and we're going to start at 0 because they clarify for us in the problem that any interval is not going to start at like a negative value, so we can start at 0. So let's just start putting these intervals into our number line and see what happens. So we have 1, 3, so I'm going to have a line going from 1 to 3, which is over here. So this interval is length 2. We'll have an interval going from 8 to 10, another interval of length 2. We'll have an interval from 15 to 18, and the last interval is from 2 to 6. So notice this time we actually do have an overlapping interval, 2 to 6. So I'm going to draw it above. So I'm going to draw it where it's obvious that we have 2 intervals that are overlapping. Now, when you actually draw out the number line, it kind of becomes obvious that it would be very helpful for us to take these intervals and sort them based on the start value. We don't care so much about the end value because we want to go through our number line starting at the beginning, starting at the start value, going to the next start value, going to the next start value, and then continuing that because this allows us to detect. So for example, we look at this interval first. We know it goes from 1 to 3. Next, we look at the second interval. It goes from 2 to 6. And since we just looked at the previous interval over here, we know that this one overlaps with this one. So what are we going to do? We're going to merge them together into a new interval. So it results in a new interval from 1 to 6, because remember, ultimately we are trying to merge the intervals. And then we go to our next starting position, which is 8. So we have an interval from 8 to 10, and we know it does not merge with this one because they're non-overlapping. We got some space over here, right? Lastly, we go to this interval, and it goes from 15 to 18. We know it does not overlap with this one. There's all this space in between, right? So just to reiterate, we're going to take our input list of intervals, sort by the start value of each interval, and then we're going to iterate through each start value, right? Starting at the first one then the next one, then this one, then this one, and each time we're going to check, okay, does the current interval, does the most recent interval overlap with the previous interval? If it doesn't, we don't do anything. If it does, which it did in this case, then we can merge them into one interval. Now, it might seem unnecessary to even have a picture like this because this interval problem is actually straightforward, right? We just sort and then we merge the intervals. But there are a lot more difficult interval problems where I'm telling you, drawing a picture like this, drawing a number line to understand what's actually going on makes the problem a lot easier to solve. So now let's write the code. Remember, we are sorting the entire input and then iterating through the input, so the time complexity is going to be big O n log n, where n is the number of intervals that we're given. So thankfully for us in Python, it's pretty straightforward to sort. We can just take interval, sort, and what's the key we're sorting by? Because remember, we're sorting a list of pairs. So the key is going to be in Python, a lambda function. So in this case, I is going to stand for the interval. And what value of this interval are we going to use? We're going to use the first value. So at index 0, we're sorting by the start value. If we wanted to sort by the end value, this would be I of 1, but we're going to sort by the start value only. And so it would be I of 1, but we're going to sort by the start value only. And so let's also declare an output where we're going to put the merged intervals. So I'm not going to initialize this to empty. I'm actually going to take the first interval and have it inserted into the output just so I can avoid an edge case. So we have initialized the interval. So now we're going to iterate through every single interval in sorted order. And technically we can skip the first one because we already added the first interval into the output. And instead of just having the interval itself, we know we're going to use the start and end value, so I'm just going to extract them like this. And so how do we know if the interval is overlapping with the most recent interval? Well, we can get from our output, this is why I added one so we can avoid the edge case. From our output, we can get the most recently added interval and get the end value of it because that's what we need to know if it overlaps. So the end value of the most recent interval, we'll call it if it overlaps. So the end value of the most recent interval, we'll call it know if it overlaps. So end value, most recent one, so we can avoid the edge case. From our output, we can get the most recently added interval and get the end value of it because that's what we need to know if it overlaps. So the end value of the most recent interval, we'll call it last end. And we're going to check of the current interval we're at, the start and end value we're iterating through. If the start is less than or equal to the last ending value, that means they're overlapping. The equal is important because they told us in the second example that we are counting equal as overlapping. So if they are overlapping, what are we going to do? We're going to merge them equal as overlapping. So if they are overlapping, what are we going to do? We're going to merge counting equal as important because they told us in the second example that we are counting equal as overlapping. So if they are overlapping, what are we going to do? We're going to merge them. How do we merge them? Well, all we have to do is take the most recent value, so at index end value, so I'm going to sort it, take a sort at if the start is less than, or what we do is take the most recent we already have in last end and the max of the current to. How do we merge them? Well, all we have to do is take the most recently added interval and take the ending value of it and set it to the max of itself, which we already have in last end, and the max of the current end value that we're at. And the reason we need to take the max is, what if we had two intervals starting at 1, 5, and the second interval is 2, 4, because we would iterate through them in this order because this has a starting value of 1, this has a starting value of 2, but notice how this actually has a larger end value than this one. So if we just take 4 and merge this together and set this to 4, we're actually making the interval smaller. We want to keep the 5 because merging these two together is going to actually result in 1, 5. So in the case that they're non-overlapping, what are we going to do? Well, we don't have to merge, but we do have to take that interval and still add it to our output. So we're going to take start end and just add it to our output. So what would be an example of that? Well, what if we had 7, 8? Right, these two intervals are non-overlapping, so the result would actually be itself, right? We don't have to make any changes. We don't have to merge. We can just leave it as it is. And that's actually it. So we didn't really have to do anything since we used the built-in sort. We took care of the main part of this problem. And all we have to do now is return the output. And so this is a pretty efficient solution. I hope this kind of explained a little bit of the intuition, and you kind of have like a visual picture of what is actually going on as we run this algorithm and why we're doing it the way we are. And I hope this was helpful.